This is Stories from the Hackery, a podcast about the students, alumni, and community members that continue to shape Nashville Software School. Nashville Software School is the nation's first nonprofit coding boot camp where a person with aptitude and motivation can gain the skills needed for a career in tech. For more information, visit us at nashvillesoftwareschool.com. Welcome back to Stories from the Hackery from Nashville Software School. I'm John Warwick, the founder and CEO of the Software School. And today we're going to talk with somebody who's been a friend of NSS for years now, Jason Turan. And we're going to talk about data engineering. We're going to talk about what Jason's been up to. We're going to talk about generative AI because it's illegal to do a tech podcast these days without talking about generative AI, and we'll see where it goes, and we'll see where else it goes from there. So, Jason, welcome. Thank you for coming and spending a little time with us today.
Yeah, thanks for having me. Always more than happy to help out with the NSS, and love that you're doing a podcast, and hopefully can offer some insights here and there.
Oh yeah, I'm sure you'll be able to. So, Jason, before we dig into to data engineering, give us the Jason personal elevator pitch. Who's Jason?
I always call it what's your origin story when I'm interviewing candidates.
Yep.
So I say the quick elevator pitch version of it, starting on the personal level. Loving husband, proud father of 2 kids, 1 6-year-old daughter, 3-year-old son. Adopted Nashville native because I've been here since pre-Great Recession and have seen when you could buy a condo downtown for $150,000, which I did not do and wished I would have. So I've been here in Nashville for almost 20 years. As far as kind of personal interests, technologist all the time, occasional writer, big geek culture enthusiast, and then really problem solver in data analytics operations, specifically in the healthcare and finance sectors or industries. Most of that being healthcare. My first 15 years was in healthcare, and the last 2.5 years have been in finance and still advising a couple of healthcare companies, and have watched the data spectrum really evolve in a lot of ways, but in a lot of ways kind of stay the same with just new buzzwords and new branding. So eager to dive into some of those topics and go deeper.
Yeah. It's funny how some of the problems just don't change.
So they do not.
Yeah. All right. So just to connect it with the software school, tell us a little bit about how you got involved with NSS.
Yeah, I was thinking about this. I don't remember when the exact connection was made, but around 2016, so almost 10 years ago, I started volunteering more, starting with the NTC, the National Technology Council, or the Greater National Technology Council, and showing up to events, networking events, and participating in some programs that they had. And it was somewhere through there that I was connected with Mary at Nashville Software School, who's running a lot of the analytics programs cohorts, and started volunteering from there for 2 reasons. One, to give back to the community in an organization that aligned with my own values and was able to give back in that way. But also to build up that relationship as a potential source of job applicants. And so that started with things like panel discussions, mock interviews, some sample projects. I was working for a company called Healthcare Blue Book at the time, and we started with myself and another individual named Michael, and started volunteering with the NSS, and that quickly expanded. I think still today, you all might still use some of the people that are still there. And it really got to a point where we were constantly involved in different events, meetings, discussions, etc. And by the time I left, which again was January of 2022, our data department, which encompassed software engineers, data scientists, data analysts, about 70% of the junior hires that we brought on board came from the NSS. So there were a lot of things that aligned just really well. And having that relationship went a long way. I've not been able to stay as involved. Obviously, kids started coming into the picture, and I'm an unpaid Uber driver now on nights and weekends, taking gymnastics and dance class and tap class and school drop-offs and pickups. So I try to squeeze in what time I can, such as this podcast. But yeah, I think that's how I got connected, and still keeping in touch, John, with you and Mary and team, and may not be able to participate as directly as I did in the past, but definitely a fan from the sidelines and cheering you all on and encouraging people to check out the school.
Well, yeah, that unpaid chauffeur role thing, you're going to get real used to that over the next 10
That's what I hear.
years.
That's what I hear.
Yeah. So, well, yeah. And the relationship, I think, has been really productive from our point of view as well. You and your team at Healthcare Blue Book, certainly, and you since then have on numerous occasions been provided really very helpful feedback on curriculum or projects or just approaches to take on certain kinds of things and preparing our students to be as job ready as possible. And that's been a great valuable relationship for us above and beyond the hiring and your engagement and all the volunteer activities. So all that, very much appreciated, you and Michael and other people who were on that team. And that sort of brings us to maybe my first let's dig in question, because you were the first person, and this is well before you left, I think, Healthcare Blue Book. So I don't know if it was 2021 or 20, but you were the first hiring manager, the first executive at one of our companies that we work with, to tell us that we should be training data engineers. I think the question was phrased something like, when do you start training some data engineers? I can't hire data engineers. Something like that. So what were you seeing sort of at the time in the maybe specifically Nashville tech landscape, or more broadly, that sparked that thought? What were the skill gaps that you saw? What were the needs that you saw that caused you to sort of get that on our radar screen?
Yeah. So I think it's a few different things, but probably the biggest one was I'm going to call it the world of data. So much focus is put on really two areas, like the data producers, which is the applications and the software that produces data. So you need software engineers to build systems, or administrators to administer systems to create data. And there's a lot of clarified, well-defined roles for that. But then you have data consumers. You have, in that case, data analysts or data scientists, and that translates into executives interpreting reports and analytics, et cetera. And when you looked at the data consumer piece on the analysts and the data scientists, I think there's some good quotes out there, like a good data scientist spends 80% of their time cleaning and enriching data, and actually 20% of their time actually doing data science. And it's sort of a facetious comment, because it should be more of the opposite, like 20% of your time spent preparing data, feature engineering, and the other percent actually analyzing data. So when you work in that kind of role, and I started as an analyst, and many people I know that are in data engineering, and we'll come back to this later, hopefully, sort of start downstream. You're a consumer, and you're creating things from the output of that data. But any good data analyst, data scientist is naturally curious. And so where's this, this data doesn't look right. Where's it coming from? How do I need to fix this? And so as a byproduct of that, you end up cleaning and enriching data yourself. And it could be as analog as pulling that into Excel and writing a bunch of formulas. But over time, you may get more sophisticated to build your own tables, whether it's in SQL or, for the rise of Python and Jupyter Notebook, let's pull some data into here. Let's build my own notebook and let's enrich the data. And so there's always a component of preparing that data in what eventually became known as data engineering that everybody was doing, and I don't think was quite formalized except in the world of big tech in the 2010s. It wasn't until really coming out of the 2010s that you started to see a lot of, I think, defined requirements for something like a data engineer to say, let's formalize this role, this concept. and have somebody who kind of sits in the middle, like you're the connective tissue between data producers and data consumers. And if done right, that Pareto principle of 80-20 should flip around to where your data scientists or data analysts, they're only spending 20% of their time. I don't think you could ever get it to zero, but where they're spending the majority of their time actually analyzing data. And so it was just something I was noticing, very anecdotal, talking to a lot of friends, colleagues, and just this recognition that there was a lack of formality. It wasn't just like NSFs. It was at the local universities, other schools where there's just sort of pain point that we were all feeling, especially as hiring managers. We didn't want the people we hired as analysts like spending all their time preparing and cleaning data. And that's where at the same time, data engineering became more formal. And so that's when I came knocking and was curious about like, where are you looking to do this and implement this? I think the good thing is just based on the work that you all have done, I think the industry and curriculums has sort of caught up with that. And that's great. So I think that's needed because I think the demand for this kind of role is only going to continue to increase over time.
Yeah, that's certainly the conclusion that we've come to over a few years. And in addition to initially you and then some of the other people, employers that we work with, bringing this up more and more frequently, the other thing we noticed was that a meaningful number of graduates from either our software development program, so on that sort of produce the data side, building server side of applications and whatever, or on the sort of the consumer side, the analysts, data scientists, that we were either seeing people hired right out of NSS into a data engineering title role, or their next step after getting hired as a data analyst or as maybe as software engineer was into a data engineering role. And with that, the numbers of those started to sort of increase. And so I think it's really kind of the convergence of that and then feedback and discussions with people like you that caused us to, much like we did with data science back in 2016, 2017, where people were saying, hey, when you gonna train some people to do this? And it's like, well, I don't know. Do you want to hire some? And then when it felt like the answer became yes on a sufficient scale, Mary got to work and we launched data science and then data analytics. And this data engineering has sort of felt like a very similar sort of organic process growing out of need identified and opportunity identified by watching kind of what's going on in the community. We also did some research using Lightcast data and found that Nashville has, on a per capita basis, Nashville has far more data engineering roles than similar sized cities, right? Which is not true for things like software engineers, right? We've always sort of had less than the per capita number of software engineers, but we definitely have more data engineers. And we've sort of scratched our head about that one a little bit. I'm curious if you have any thoughts or insights on why that might be the case. Kind of the best theory I have is, well, quality data has become so critical in healthcare, and that's our biggest industry, so maybe that's a driver. Mm-hmm. But I don't really know. Any thoughts?
Yeah, it's fascinating. I saw that in the show notes the leading up to this, and I guess it surprised me in some ways, and in other ways maybe not. I mean, this is all anecdotal, but you can't talk about any trends or statistics in Nashville without anchoring it to healthcare somehow. And it's like, for anybody watching this, you hear Music City, and obviously music and entertainment is a huge portion of Nashville, but it's a drop in the bucket compared to healthcare. There's a reason Nashville is considered the healthcare capital of the country. It's been several years since I checked this stat, but I think over 300 companies were either headquartered out of Nashville, healthcare companies, or have a major regional presence here. I would guess, and I'm totally spitballing here, but having worked in that world, the need to have somebody to be able to extract data out of multiple siloed systems is probably more acute in healthcare than a lot of other industries, because of the regulatory hurdles you have to work through from a compliance to regulatory HIPAA standpoint. a lot of healthcare systems don't have this data just sitting in an easily accessible S3 bucket and S3 where you can pull in and build a data lake against it. There may be some data that's like that. You can certainly build it that way and check all the compliance boxes, but a lot of these systems are running on old like SQL Server Enterprise or Oracle servers, and you've got EHRs that are running, you've got claim systems that are still mainframe based. And so to get all that data from a data warehouse standpoint, I mean, that was a huge problem. When I worked for prior Blue Book, HealthSpring, which was bought by Cigna, so a major insurer, I mean, that was all the case with that. So I'm guessing you have a lot of need for data engineers that have to pull data from all those systems. And because it's so disparate, it probably doesn't scale as well. And what I mean by that is you can't just get one data engineer that can handle 20 different pipelines because they're so bespoke and so challenging on an individual level. You probably need 2 or 3 data engineers to do that. And so I think it's a good problem or a good thing for Nashville. I think it also probably points to, if it is healthcare based, that some of the challenges within healthcare and being able to break data out of those silos, especially, I know we'll talk about this, like what does that mean for generative AI and how that can improve things. I think it only further shines a big bright light on the inefficiencies of that architecture and how we need to solve for it.
Right. Yeah, the cumulative investment over the years, though, in building these siloed systems is not an easy thing to overcome, particularly when they're working, right? It's like, hey, it ain't broke.
Yeah, something to be said. I mean, you got these mainframe systems, some are running on like COBOL, Fortran, 30, 40 years old, process claims data, and it works. So the trade-off costs of suddenly switching to a new platform, a cloud-based US East 1, AWS, that goes down and everything is down, versus you have an old school mainframe IBM server running. Like, there may be 2 people in the country that built that software specifically that can fix it if it's broken, but it almost never breaks. So there's something to be said about that. I think something to aspire towards, not just go all in on something like the cloud, to say like, okay, there's a reason these systems were built, and to not take it through sort of a critical lens, which is probably what it sounded like for me. It's like, oh, it's because it's all regulatory security compliance. Like, that's necessary. I mean, I've been the compliance officer at a company before. Like, you have to do those things. But there's, I think, a lot of little lessons to be learned from that on why things are set up the way that they are.
Yeah. Some of this is just the way that things have evolved over 30 or 40 years, right? And constant waves of new technologies and new architectures and new regulations. Now, you're in finance world now. That's another, at least in pockets, heavily regulated industry with lots of legacy applications, probably.
There's so many similarities. I thought it would be, I don't know why I thought it might be different. You're basically swapping acronyms. Instead of HIPAA and CMS and HHS, it's GLBA is the version of kind of HIPAA for finance, and IRS and SEC and FINRA. But it's the same concept about having the right security posture and guardrails in place, because instead of personally identifiable health information, you're talking about people's banking and payment information. So just as important. And yeah, same thing. You have a lot of these platforms that are built, still running on legacy systems, and there's a lot of parallels there. And so I guess I'm a glutton for punishment. I hop from one massively regulated industry to another, but still enjoy it and just learning all the new acronyms and new systems.
Yeah. Well, Jason, just let me give you a hint. If it's time to move to the third industry someday, don't let it be education, because it's
okay. All right. Noted.
All right. So a number of the things you've already sort of alluded to, several things that kind of tie into one of the things I want to talk about. I said Nashville has per capita more data engineers, but we've also we've looked at, again, using Lightcast mainly as a data source, we've looked at job posting trends over 5 years nationally and locally. And it's clear that data engineering is a growth area right now. maybe that's because we got lots more ways in which to consume that data for more types of decision making and analytics and whatever. I don't know. But since again, you've been embedded in that for so many years, kind of what sense do you have about kind of what are some of the drivers for that, and what new things have emerged to drive that, maybe that accounts for some of that accelerating growth? Just again, sort of, what have you observed, or what do you believe about that?
Yeah, this is one where, especially now, to me, the answer to this one's really clear. There's a lot of things, like every year that I'm in this industry, like I get less convinced that what I thought might be the case. But this is one where this one's always held true, especially in the world of generative AI, LLMs, etc. But let's hold off on that part for a second. When you think about just analytics in general, descriptive analytics, you are looking at data and extracting insights from that data. And we'll even go into, like, it's funny, data science is like an older term now, right? Like a machine learning engineer, or even part of data science, statistics, right? Or you're able to make predictions. So predictions and prescriptive analytics, et cetera. Like the quality of your analytics and your insights, or the way that you have high quality analytics as insights, is by having high quality data. And the way you have high quality data is by having high quality data engineers who understand not just how to do something, but the who, what, where, when, and why, to link all those pieces together so that you have the right context. And when you create that data asset that is then consumed, it is the highest quality output possible. And there's a direct correlation on high quality data, and I could spend a couple hours talking about different scenarios in healthcare or finance where low quality data leads to low quality analytics that can lead to decisions made by your executive team that are not based on accurate information. And that's bad for obvious reasons. But I think tying back to the generative AI LLM, since we have to talk about that, I said, the key to having high quality analytics, in this case, the LLMs produce better output when you have high quality context, because you load context into LLMs. And it's the same thing. The better quality, your high quality context is based on high quality data that goes into the context. Just think about unstructured sites. If you're scraping a 4chan site of text and that's all you build your LLM off of, then your answers are probably not going to be great. But if you are scanning something, you could have specific subreddit forums or Stack Overflow sections of the site. Like the data that's going into that is going to lead to better output from your LLM. And then now, in the latest really growing trend of focusing more on structured data, MCP servers, model context protocol servers, like a REST API, for being able to connect to a number of different services, including a database. It's very sort of new frontier, Wild West work, where you can actually create a connection that an LLM can then access a SQL database. Like that just magnifies the need for you to have well-structured data, because if the LLM cannot infer from the data that you have what it even means, and what is the context improperly, then you result in inferior output. So I think the accelerant in popularity of that only adds to the demand of having great data engineers to ensure that data is prepared correctly. Of course, those data engineers, now there's a lot of AI-based tools that they can use, but you still need somebody playing air traffic control to make sure things are coming and going as they need to be. I don't think we're at that spot yet where you just go hands off the wheel. But I do see that as only increasing the demand for data engineers. And so I think that's a good thing. Good thing for the NSS, good thing for anybody who's producing the supply of talent.
Yeah, I think that's right. I totally agree. And I like a couple of the words you used there. The generative AI as a magnifier or an accelerant, in the way that I think machine learning was starting, I don't know, 10 years ago, maybe. Maybe it's a little more than that, compared to prior to that, when we were mostly doing descriptive analytics and things. But even descriptive analytics highlighted how much cruft there was in hard to old data, right? So, and it's like every step we make, we realize garbage in, garbage out to go back to the early 70s when I started. So, and we've always known that, we've always kind of known that good data is a prerequisite to getting good outcomes from our systems, right? Whatever those systems are. And so, and I think machine learning certainly started to accelerate that awareness. I think you're right on that. And the generative AI stuff, if you're going to train a model and get good answers or post-train something or set up a RAG system so you're not at the mercy of a massive general purpose LLM or whatever, it's subject to the quality of the data. And then you also have to deal with the structure, get even better understanding of the semantics of your data, all of those kinds of things that we wrestle with.
Yeah, I think it also uncovers some almost a contrarian viewpoint to how we've typically done things in the past. So the intent for a data warehouse has always been to create highly structured data. LLMs work well with unstructured conversational style data. And so there's a pretty big difference if you just take raw data, even like a JSON or CSV format, punch that into an LLM, or if you can translate that into more of a conversational style paragraph, 2 paragraphs, however long it might be, and then put that into the LLM, because those are built off of understanding like human language. And so it's almost like, yep, we've told you to make this structured, but oh, by the way, to make this work really well, we need to make this a little more unstructured again. And like, how do you do that? And how do you make that more conversational? There's some, like, again, very frontier, interesting things. And then with whole MCPs connecting into SQL, like I'm very keen to watch that space. Like, will that continue to be true? Will the LLMs be smart enough to assemble that context themselves? Like, I don't know. The space is evolving so fast that I feel like anything that I say in this podcast might get refuted by tomorrow because some new company or tech has come out that addresses that.
Right. Yeah. Or have we figured out ways to pair other techniques with LLMs? Mm-hmm. Right. Because at least transformer-based LLMs there's a lot of thought that there's limitations to what that architecture can be scaled to do. But yeah, I mean, it is evolving so fast, and trying to figure out how to stay up with it, right? And it's like, who was it? Is it Ethan Mollick? One of the pontificators on all of this talks about how the leading edge of this is jagged, right? Yeah. And projecting from what you see as capability or lack of capability in one area doesn't necessarily map very well to other problem spaces or other tech. So
it's eerily reminiscent of when the web was first introduced, late 90s, and people forget that you didn't just open up a browser. I mean, there were some walled gardens, whether it was AOL or other companies, and it was a weird but kind of fun, frustrating, curious space to be in. And this is the first time since then, and I was like more in my teenage years when that happened, where it feels like that again. It's almost like throwing darts at the wall. Like, how will all this play out? Who will be the winners? What will be the general approach 5 years from now, 3 years from now, maybe even a year or two from now? It feels like that again.
Yeah. Oh yeah, absolutely. That resonates with me, because it feels like that. And the last time before that I can remember, because I'm a couple of years older than you, Jason, it was the PC, right? Mm-hmm. All of a sudden, right? It's not locked in a computer room anymore, right? It's on people's desks. Oh my God! Talk about heart failure on the part of IT people. Oh man, there's been a jailbreak. So, that cycle took, I don't know, how long did that take? 20 years, right? And the internet arguably, which then got mobile compounded on top of it about 10 years later, right? Arguably took at least a good 15 years, maybe 20. And so where are we with this? Now, this is happening really fast. It feels like this has happened faster.
Cycles are getting shorter, it seems like.
Oh, yeah. That's what it feels like. But so what, one thing that's obviously very relevant for us, is what does this mean for people that want to get in to this world, right? People that want to build things with software, right? It's like, on the one hand, you hear, oh, we won't need programmers, which I think after 2.5 years of this, I think we're figuring out that that's BS. But it's changing the nature of what it means to build software, to craft software. Maybe I'm not writing as much code, but there's still lots of things that, and I think those things are still true. That's probably true in analytics and data science. I think it's probably true across all the things in tech. But how should people who want to get into this be think about approaching this as a career field, right? Because out there right now, there's hot takes everywhere from do anything but, right, to, oh man, this is all just going to blow over. And there's a lot of room in between those two things. But what do we say to people who like solving problems with data? They like answering questions with data. What do we say to people who are the builders, the makers, who would have come to software engineering if people weren't trying to scare them away from it now? So curious, based on what you're seeing, and again, I know this is a moving target, but sort of what's your thought on it right now? Where's your head, and what advice would you give somebody?
I mean, there's never been a better time right now than to get into this field. And there's a few different, I think, components to that. Like the first one, just like any jobs, like data engineering can be very lucrative in terms of pay. And for anybody watching this, if you're just moving into a field because of the dollar signs, clearly you need to prioritize what's important to you and your family. And if that means making ends meet, go for it. But no, like if you don't have that curiosity or that excitement to solve problems, you're going to hit a ceiling pretty quickly, I think. So that's just one sort of general advice, technical roles overall. But the barriers to entry to learning about data engineering have, again, never been lower than before. So let's go through a few iterations here. 10, 15 years ago, and I'm going to kind of couple analytics and data engineering together here, but your data platforms, cloud was not like it is today. Most of your enterprises were running things like SQL Server or Oracle, so you did not have access to that. Software with things like SPSS and SaaS, so commercial software that you should pay for. And if you were enrolled like in an institution, like a university, like they might have access to this. And so it's like information asymmetry. I was working against you for so long. So what has happened since then? Well, the proliferation of the cloud, one thing. So now, and the cloud and open source, I'll pair those two together. So the ability now to be able to spin up a low-cost instance of something, whether it's AWS, GCP, Azure, or something like DigitalOcean for $5 a month, you can spin up a database instance and have something to work with. So again, that barrier was lowered. And then the popularity of more open source databases, specifically Postgres, MySQL, since Oracle bought them, I would argue is not developed at the pace that it probably needs to. You've got MariaDB and some other solutions.
But Postgres seems to be.
Yeah, well, if you go look at Postgres 18 that just came out, like phenomenal features, like I don't know, the geek culture or the geek in me is like, OLTP data design, but like some of the things that you're like, yes, like I want to go out and play with this now. So you also have things like Docker, being able to containerize, and which also ties to just how powerful our local computers are now. Our computers now are more powerful than most servers were from 10, 15 years ago. So within a few lines of code now, you can run a command that pulls down an image and spins up an instance of a database and a development environment to be able to work in. And so in that case, you had Python, which became sort of the gravitational kind of center of that, and the rise of like Jupyter and Pandas for exploratory analysis, which was good. Again, open source technologies, being able to install and set that up. I would still argue for somebody brand new in the space of, say, Python, like setting up Python and the versions and your virtual environments and get everything ready, like that can still be a little intimidating, but it was doable. Get barriers to entry lowering there. But like now what you have, there's so many new companies that have lowered those barriers even further. And I'm going to give a huge shout out to one I've been playing with every single day, which is DuckDB, built by DuckDB Labs and their commercial offering, MotherDuck, which sounds like a playful name, but very, very powerful software. And you can, in like 3 lines of code, have a piece of software installed that launches a web browser, and you can write SQL queries against a CSV data set. Like you can do in 5 minutes what used to take you like 5 weeks to set together. And so the barriers to entry are low, and there's no excuse now to say, well, I don't have access to these tools. And a lot of people need that sort of guided curriculum like what the NSS has, where it's like, I'll go learn on my own, but I need somebody to help work with projects, etc. And so like you take all those in total, like anybody can get in and learn this stuff. Everything is out there. Those huge barriers to entry no longer exist. So take that coupled with the demand for higher quality data, again, for descriptive analytics, or whether it's for LLM, and it's like the peanut butter and chocolate, like just sort of meeting, and just like it's like a perfect setup. Now, will it continue to be that way? I think it will well into the future. I don't see data engineering going away. But the timing is great. And to anybody who's thinking like, oh, I'm going to get vibe coded out of a job, I can tell you as someone who is in LLMs like every day and who's paid for a number of LLMs when it comes to generating code, like we're not there yet. I was on ChatGPT 5 the other day, putting it through a test run, and it still just makes some very like cringeworthy mistakes on like writing code. There's some other things I want to come back to in a minute that I think are more powerful than data engineering sort of tool belt for LLMs, but like writing code for you, there's so much bad output that still gets produced. But you can do like using things like writing unit tests or like paired programming in some ways that I think it can be really powerful for. So I'm kind of hitting like a lot of different areas, but all those to me just make it feel like this really ripe opportunity. And finally, the last one, which gets into a little bit of tech specific feedback. I'm actually a big fan that the data engineering world is becoming less dependent on like Python specific. And I'm specifically talking about DBT, which ironically part of it runs in Python behind the scenes, except their Fusion engine, which is newer. But this idea that data engineering, it started to sort of like drift away, and like to do more advanced data engineering, you had to learn complex Python and PySpark, etc. That's not the case now. Like with tools like DBT, SQL Mesh to a lesser popularity, you can now keep it all SQL based and be able to do, for the most part, most of your like data transformations. And so this sort of sprawl that happened over the last 10 years, there's been, I think, some retraction to where you can keep a fewer number of tools in your tool belt and focus on those and not feel overwhelmed by so many different things. So I think all those add up to why I think it's exciting to enter into the space and just go look at job postings with companies like that. They're not slowing down on hiring these kind of roles. So I think if you're wanting to learn those skills, it's as great of a time as ever to get into it.
All right, great, thanks. Yeah, the being able to do more in SQL is also interesting. I was reading something interesting last week. One of the data meets AI Substack newsletters was talking about as flaky as the LLMs can still be in generating code, they're even less effective generating SQL.
Yes, preach. I've seen some really bad SQL generated. We've actually, at the company I work for now, we've actually done some tests like on could we ship some of our work entirely and very quickly within a few hours. Like, nope, we're not using it for that. But there is an area, I want to make sure I hit that. There is an area where I do think for the data engineer that people aren't talking about enough that the LLMs are really, really good at.
Well, let's go there then. Yeah.
Okay, so this is recent for me, and as probably a lot of people have done this since LLMs came out. And I'm like, why are you saying that it's new? But the light bulb really went off where when you think about as a data engineer, I mentioned earlier, you're good to go from good to great in data engineering. You need to transition from the how, like how do I do this? How do I just work this ticket, to the who, what, where, when, why, and connect the dots. Who is this coming from? Like why is the data work this way, and where I'm coming from? And it's that natural curiosity and a healthy dose of skepticism will sort of lead you to asking those questions. And when you're building, whether you have your own project manager or you're doing this yourself or your boss and you're working with requirements, in order to build a data set that has the right elements, you need to understand contextually, like, what is going on upstream in the source systems. So we have it in my current company that I work for. We've got a monolithic PHP code base that has a lot of legacy code, very massive code base, well documented. We've got a number of microservices as well for some of our newer technology that we're building out. And what we've started doing, what I've been doing and other members of the team, in the past, if we needed to build some new data points, we had to actually go into the code and look at it ourselves. And like, I can read PHP and enough to be dangerous to see kind of where things are going and sort of clicking through the searches but often talking to principal engineers, how this works. So I might spend several hours gathering all the pieces needed to say, all right, here's exactly what's going on this one particular field is created. And here's what this means and how we need to clean it or enrich it in our output. Now, clone the repository in your local machine, assuming you have access. Running something like a Claude Code or a Warp that has access to look in your code base, you can actually ask questions against it to say, like, I want to understand how these two fields are used in this app, why they are different and where they're similar, and let it do its thing. And it will actually search through your code base, load all the proper context. You can select whatever model you want. They all have pretty high quality output, and actually will generate documentation for you that shows, like, here's what these two fields do. Here's how they are related. Here's the steps, and you can tweak it a little bit more and ask for other things. And what I've been doing is taking that, pulling that documentation out, saving it into our Confluence wiki, and then using that in conversations with the rest of the team to say, all right, here's how all this works. So I was able to last week in about 30 minutes do what would have probably taken me about 3 hours of time of just research. This is no coding yet. It's just gathering the proper information to enhance your data models. And I think using it that way is something, I know for me personally, like, the light bulb went off, like, oh, I'm going to use this all the time. And it's a way that you can move faster and not just think that using an LLM to create code. No, you can actually ask it questions against your code base, assuming you have the access and permissions. That's my new favorite use case for it.
Yeah. Okay. So yeah, we've been saying, and we're actually spinning up some continuing education training on how to use these tools effectively to understand an existing code base, right? Because most new people, when they get hired, they don't get hired into a greenfield world. They get hired into brownfield world, and it's brown for a reason. So how do you understand all of it? And that's interesting, thinking about the sort of 90-degree twist. This is not about understanding the code and the architecture of the code, but this is about, how does this data get created? How does it get manipulated? So that I understand it, because that's great. In so many organizations, that's even worse documented than the code is stuck, right? I mean, it seems to me we're cycling back. I'd be curious about your feeling about this. We're cycling back on what's been a problem that feels like it comes up every few years, and then kind of goes away, and then it comes up again, and it's the metadata issue, right? How do I understand my data, right? And where it's created and how it's manipulated and what does it mean? And does this really mean the same thing in these three systems that allege that they're all creating the same thing? It seems like you're suggesting that the generative AI offers us or might offer us even greater capability down the road as we maybe train some of the tools specifically for this job to really help us understand our data better, right? So I don't know what's your reaction to any of that stuff I just said?
I mean, that's again my favorite use case, but also back to the question for people getting into this space. I'm going to shift over to software engineering for a minute, just because it's more personal for how I've used it. But I like on the side dabbling in web app development, and if I'm using Python, I like using Django or like Rails and Ruby, which I'm less familiar with. But these are all open source frameworks, libraries. you can clone the entire repo. Now, in the past, if you tried to say with Django, because a lot of data programs with Python, so a lot of people will learn how to use like Flask or Django because it's Python. But if you open up like the Django Codebase, I mean, it goes back 20 years or so. I mean, it's very intimidating. But if you have that code base and you have a tool like a Claude Code or Warp and actually ask questions against it, it's like kind of an instructor in a lot of ways. Like, tell me about how the ORM works with Django. You can sort of cater the answers. And so rather than try to dive in and figure out things yourself, you're asking it to search through the code base, and then you can have it hit other topics. So when you're wanting to learn, back to data engineering, like, I don't know, Airflow or one of the many open source packages, like, how does this work? How does Airflow handle DAG orchestration? Like, but you could say, like, summarize this for, I only have 1 year of technical experience, and it can cater its responses to that. So
right.
There's that educational component, like, to be able to do that we just didn't have before, and how you can really kind of supercharge your ability to learn.
Yeah, and I mean, just in the last couple of weeks, we're seeing now LLM versions that have capabilities tailored to the learning problem, right? Mm-hmm. I mean, I know who was it? ChatGPT released one. One's called Learn, one's called, I don't remember what the other one is, and which are again, this use case of a learning assistant or a learning tool or a tutor or a Socratic coach, which you can prompt them to get them to do that too. That we think that has a lot of promise, and that's the first use case that we generally are really teaching our students in terms of how to use LLMs, even before we get to writing code and all of that, because there's a lot of caveats around that part still, right? And we still firmly believe you have to know the fundamentals to use these tools effectively to build enterprise solutions. Yeah, I can vibe code a throwaway app for myself maybe, but if I'm going to put this in production somewhere, I've got to know how to verify that the code's valid and that right. So
I think too, if you're in healthcare, finance, heavily regulated industries, I mean, it's easy to jump on board and hooking, like creating an MCP server that can get directly into your SQL database. But now you're in this, you can do that now at very low, no cost. But for companies that are highly regulated, you need to have like enterprise software agreements in place, whether it's OpenAI or Anthropic. With healthcare, they're going to have signed BAA. They're not sharing data that's being sent, or you have to stand up your own infrastructure in like AWS Bedrock, which can then host the models and instead of actually pushing the models directly out. So by nature of working in a heavily regulated industry, you're going to be constrained on being able to use some of these tools. It's a forced constraint, but again, it's one, like, spin that around to your advantage and learn the fundamentals, because I don't think it's very different now, like with vibe coding questions in a reporting tool, which I'm excited to see where that goes. I remember my first job was running in the data world, was responsible for a business objects crystal reports instance with like 300 reports. And it was all dynamic SQL because we had no permissions to do temp tables or anything else. And you could enter parameters. And sometimes our users would put parameters in that would cause these cross joins. It would literally crash the entire server. We would have to tell the company, like, the server is down for the rest of the day. You see that now in a lot of memes or comments like, yes, somebody was vibe coding and here's the actual execution plan that's generated from SQL. And this one person brought down our server 10 times because of the vibe coding, which again goes back to, like, how do you put the right guardrails in place to where it knows and can work with the SQL engine to generate the right execution plan, like, versus having a really focused data engineer building out the right index structure, the right architecture, so that when those questions are asked, you have like millisecond latency, if that. We're not there yet. I think it's only going to improve, but that's an area where if you just lean too heavily. It's like when we remember like GPS systems, even before on our phone, like a Garmin, we used to always look at maps. But then what happens when the GPS system goes down? You just sort of malfunction. You're like, I don't know which way's north. I don't know where to go. And you're like pulling off the interstate exit and looking at the map. My mom used to keep a Rand McNally travel guide in the back. And I'm not saying you stock up with all that, but it says something to know the fundamentals. Because if you don't, then all this investment into AI to automate processes and make things better, it's going to come back to bite you when nothing runs as efficiently as you thought because the underlying architecture isn't right.
Right. So funny. I love the analogy. Yeah, it took me a few trips after having a GPS to stop going to AAA to get a triptych for a long drive across country. So I'm guilty.
Yeah. I mean, I've same things happen before, like GPS or phone dies and you're like, wait, I don't have a map. What am I doing? And it's kind of that moment of panic, and it translates into business.
Absolutely. And as you say, we're not there yet. The tools are not there. And again, I think even more so with generating SQL effectively compared to code even. So interesting. All right. Cool. Well, I'm looking here to see if we've missed any big topics that I had wanted to hit on. I think you've talked some about kind of where this stuff is. Still good, still a good career field to get into. The dependence we have on high quality data to make all of this other stuff work is not going to change, I don't think, right? And
I don't think so.
And we're a ways away before the tools are smart enough to put us all out to pasture, if that ever happens. And it could, but my own 2 cents worth is that's going to take augmenting LLMs with some other technologies to do that. A prediction engine, which is basically what an LLM is, has trouble with some of these other things, which is not to say other technologies might not come along. If Gary Marcus gets his way, it'll...
Yeah, exactly. I do think this was in some of the show notes about like misconceptions in the field, and this was one I did think about some. Like, what are some common misconceptions? I realize the perspective that I'm speaking from may not be applicable to everyone, especially if you're working for a larger company. But this idea that you need to know how to do all the tools, everything, especially distributed computing, especially like heavy Spark jobs running EMR clusters. And I still write code every day. And in almost 20 years have never had to write like a production Spark job. I've done stuff like personal things, but for like streaming data in real time, again, there's tools like Apache Flink and Kinesis, etc. Like, there are companies where that is absolutely critical, and it's a very specialized role. But I think some people get overwhelmed with like, I need to know SQL. I need to know how to like version control my code in GitHub. I need to be able to spin up a cloud infrastructure. I also have to know distributed computing, and I need to know Spark. Like, I would argue like it's a T-shaped skill set, and that big vertical spot is SQL. That is the most critical skill in my opinion to learn. And then learn how to do general programming in Python. Understand like why and how when companies would need like streaming jobs or distributed computing jobs. But I think that's a deterrent to a lot of people, and it shouldn't be. I think I would encourage people to think more in minds like, not every company is big data. Everybody thinks that they have big data, and big data now is not what big data was 10 years ago. Like, processing 10 terabytes of data now, you've had to have almost always a distributed computing architecture, like on the Apple in silicon chips. Like, you could run that locally as long as you have enough RAM. The paradigm is very different. So don't be deterred by like the sort of all the different tools and tech. Many of these were built out of big tech firms who needed to solve for that. And just like if you're building a web app, I would encourage you, like, don't go all in on microservices, build a monolith, or don't worry about Kubernetes cluster, like just spin up an EC2 instance and deploy your app. Like so much of the internet still runs that way. Same thing with data. It's like there are some fundamentals that you need, and to not be so intimidated by all these sort of specialized roles. Know what they are, know why those problems might be used, and know that you may get hired into a role where like you're expected to learn that, but it shouldn't be a requirement for entry-level jobs for things like that.
Okay, great. Well, maybe before we do a quick lightning round on our way out, anything else that you thought of in sort of preparing for our conversation that we haven't talked about that you want to make sure that we do?
Yeah, I think I just think about the audience who might listen to this, and an overarching theme is one. Like I'm sitting here sharing all these things and advice, etc. But when you're early in your career, I'll just say, I think advice matters less, and just experience is more important. Like go out and just do the thing. Go out and just like make mistakes, and don't worry about somebody telling you the way that you're analyzing something or building something is wrong. It's like if you can watch 1,000 YouTube videos on how somebody plays an instrument, but until you actually start playing the instrument, you're not going to learn it. Same thing, like my daughter took a soccer shots class, and we try to talk to her about how it works, and then she's on the field like running in the opposite direction. But after a couple of these, it's like just go out and do the thing, and experiment and build up that evidence of work, and save that work, put it out into your own like GitHub repo, public, private, doesn't matter. I don't think people do that enough. I think everybody wants that. They just want that exact advice on what to do and what to focus on. It's like, what are you curious in? And just go out and experiment, because the barriers to entry are almost zero. But so many people that I talk to that are trying to get into the field, like that's not there. Like they've not, it's not even an initiative. It's so easy to do that. And so I think, just jumping in and experimenting with yourself. And when you do it the first time, it might take you 3 months, and then you'll learn so much from it. Say, I'm going to do it again, but you'll do it in 3 weeks. And like save that, keep that, be able to share that story. Not enough people do that. And I think that's a really powerful experience that you can have, that you can share with others or with companies that you're interviewing with. So that's probably the one thing I want to call out to anybody listening.
I think that's fantastic advice. And I think particularly today, where everything's in a state of flux, nobody's an expert on generative AI. Nobody's an expert on it. It is very similar, going back to sort of your analogy to how it was like when the internet came along. Nobody was an expert on the internet. You could have 20 years of programming experience. You didn't know anything about bringing up a web server or whatever. And so the people that just grabbed onto it and ran were the ones that ended up shaping the future.
Yeah.
So, and I think that's another way that this period in time feels to me very similar. So same thing was true with the PCs, the people that grabbed it and ran, man. So I think that's really solid advice, Jason. Thank you. All right. Well, we have used a bunch of your time, for which we're very grateful for you giving us. But I want to hit you with a couple of
lightning round. Fire away.
Couple of lightning rounds on the way out. And you've referred a couple of times to that inner geek is not very far below the surface with you. So what's your technology guilty pleasure?
2 right now. I'm going to give another big shout out. My Metabase, from an analytics standpoint, is one of just my favorite pieces of software that I've ever interacted with. If you're not using it at the NSS, that's my shameless plug to start taking a look at it. But great team, engineering led, open source version that's free, that is very, very like functional, fully featured, and with an enterprise or pro version that's very affordable and worth every single penny by far my favorite analytics tool. And then the other one I mentioned earlier was DuckDB, which is the open source version, is maintained by DuckDB Labs. And then there's MotherDuck, which is their cloud warehouse vendor, which is more of a competitor like Snowflake, Databricks, but I think more affordable. Still have some areas that they need to improve for the enterprise market, but I don't care about that. It's more of like just getting in, having fun, very like proactive team on both. And those are what I sort of tinker around with right now. When even on like my personal time, just because again, a few lines of code, you can have this stuff installed running locally and run it on your own data, or pull your bank statements down, look at your own, do your own analysis. And you couldn't do that 10 years ago. So those are the two. There's many others, but those are the two that I spend most of my time in.
All right, cool. Great. So do you have any favorite great follows to recommend for podcast or a newsletter or a blog or?
Yeah. I mean, I listen more on my like podcasts and newsletters to less about like data engineering or data science, data analytics. Like I subscribe to the TLDR newsletter. They have a few different ones. That's always a good one. But more people who are subject matter experts in different industries, like in healthcare, for example. And when it comes to like interoperability, data exchanges, someone I've gotten to know over the last few years, name's Brendan Keeler, otherwise known as the Health API guy. He writes an amazing Substack where if I want to learn about this huge CMS 2,000 page document that came out, what does it mean and how does it affect interoperability within healthcare? He has the same level of passion for that as I do, like the tech I've talked about, and he'll distill all that down and share that information. Yeah, I kind of at that point in life where I'm not as, I used to subscribe to all these different newsletters specific to, again, like data engineering, but I found that you need that healthy balance of, I don't want that time to be that and then when I'm in work and I'm as a natural byproduct going to see this. I mean, I will say related to that, I think there's some evergreen like books, anything of the books by Ralph Kimball, Bill Inman, Edward Tufte. These are all guys from the analytics, data warehousing world that their books are 30 plus years old now. And while the technologies might have changed, the philosophy, the core fundamentals of how you need to think about structuring data and business domains is again more just relevant than ever. I have copies of all those books somewhere in this office, and sometimes we'll go back to those and just kind of read up on those. So those are some of the immediate ones that come to mind.
Okay. Well, yeah, it struck me when we started to get really into data engineering. I mean, because Inman goes back. I mean, Bill Inman goes back to the early days of relational database. I mean, 70s. And Kimball, I became aware of somewhat after that. But I think
Kimball's book came a little later. Inman's book came out. I was actually looking before this podcast. The Building the Data Warehouse first edition was 1992. And he'd done stuff before that. Kimball's book, Data Warehouse Toolkit, came out in 96. And then Edward Tufte, who I'm going to launch it, but he's more like on the analytics side, like OG of analytics. He wrote 1983, The Visual Display of Quantitative Information, which I think is the greatest analytics book written. But they all hold true like so well over time. Makes me appreciate what they contributed to the community. I think a lot of people overlook their contributions and realize just how much of what you see today goes back to things that those guys wrote about, talked about decades ago.
Yeah, and I agree with you. They're just as relevant. The Inman, Kimball, understanding your data modeling, all of those. And Tufte's just, I mean.
Yeah, I saw him live. I actually watched him present live and met him, and it was just a kind of a surreal experience. It was amazing.
Yeah, great. Yeah, and I bought Tufte's books as great examples of how to think about design, even before really thinking about them as data visualization or analytics, and just brilliant stuff. I think that's a good place for us to wrap up. There's some great resources there for people. And if they're not aware of Inman and Kimball and Tufte, if nothing else, look at the visualization of the Moscow campaign and
probably
tough
the
to-
probably the greatest visual of all time. I agree. I used to have a printout of that, and I don't know what happened to it in my office, like on the wall, because it's hard. We need another 15 minutes to explain on here, but
Right.
anybody that gets that book, take a look at it, because that visual is couple hundred years. I forget how old it is at that point, but amazing.
But yeah, very, very amazing. That was why I bought the book, because I saw that and I'm like, okay, and that's brilliant. I got to get this. So, well, Jason, thank you so much for your time this morning. I really appreciate some great insights here that we will pass along to the community and make sure our data engineering students and analytics and software engineering students get exposed to. Appreciate also all of your support for Nashville Software School over the years. It's a lot of, that's one of the dimensions of what makes NSS go for all of us at the school, is support from people in the community that give of themselves to better our students and benefit our students and benefit the community. So thank you for all of that over the years. And you're going to have your hands full with kids here for a while yet, but hopefully we'll be able to pick your brain every once in a while. So thank you.
Thanks. And likewise, thank you for what you're doing in the community. Like, you're giving people an outlet that they may not have had for non-traditional education. And I think that's a really powerful thing, without this preconceived notion that you have to go back into a university and accrue the kind of debt. It's an option that was not available, that I think carries a lot of momentum in how somebody wants to take their career. So keep up the good work.
We're trying. Thanks, Jason. All right. And thanks to all of you for listening. You can find links to many of the things that were mentioned on today's show in the podcast, in the show notes, as they say in the podcast game, below. Yeah. Hear more insights like these when you visit NashvilleSoftwareSchool.com and check out some of our other podcasts if you haven't done so before.